Smart Solutions. Add-on desired.
Good morning students, welcome to Added Solutions. This is Bhavani, your maths faculty. In this session we are going to learn about applications of trigonometry for class 10. In the previous chapter trigonometry we have learned what are the trigonometric ratios and what are the specific values of a specific angles and some trigonometric identities we have learned from the previous chapter. In this chapter we are going to learn about the applications of trigonometry, where we use this trigonometry in our daily life. Let's start the class. Here it is some important concept. Let the understanding through some examples. Vijaya wants to find out height of a palm tree. How to find the height of the palm tree? She tries to locate the topmost point of the tree. She also imagines a line joining the topmost line and her eye. So she is standing and looking into the topmost in the palm tree. This line is called the line of sight. So where she is looking from the angle between she is looking from eye to the topmost is called the line of sight. She also imagines a horizontal line from her eye to the tree. This is called a horizontal line. Horizontal line. And the tree from the right angle triangle. To find the height of the tree, she needs to find a side and an angle in this triangle. So here we need to find out the height of the triangle. She need to find out a side and an angle in this. See, for finding the height of the triangle, we need compulsory any one of the one side. Out of the three sides, we need required one side and one angle. The line of a sight is above the horizontal line. The angle between the line of sight and the horizontal line is called this angle of elevation. The angle between line of a sight and the horizontal line is called angle of elevation. It is very important concept. What is angle of elevation? So the line of a sight is above the horizontal line. The angle between the line of a sight and the horizontal line is called angle of elevation. Now we will see what is angle of depression. Suppose you are standing on the top of a school building and you want to find out the distance of a borewell from the building on which you are standing. See, this is a borewell and you are standing on the building, school building. For that you have observed the base of the borewell. So then the line of a sight from the eye to the base of a borewell is below the horizontal line. See, this is a horizontal line, the angle is below the horizontal line. Here the angle between the line of sight and the horizontal line is called the angle of depression. Now this is the angle of depression. When you are observing the angle from her eye to the borewell is angle of depression. Now drawing a figures to solve the problems. In this exercise, in this chapter completely, we are going to solve the problems compulsory based on the figures. First we will draw the figures based on the question, then we are going to solve. How to draw the figures? See here. When we want to solve the problems of heights and distances, we should consider the following. All the objects such as towers, trees, buildings, ships, mountains, etc. shall be considered as linear for mathematical convenience. So here we are going to mostly find out the heights of the building, towers and mountains like that. So here consider all the mathematical convenience, we will take it as a linear figures. The line of elevation or angle of elevation or angle of depression is considered with reference to the horizontal line. The height of the observer is neglected if it is not given in the problem. When we try to find out heights and distance at an angle of elevation or depression, we need to visualize geometrically. To find the heights and distances, we need to draw the figures, and with the help of these figures we can solve the problems. Let us see with some example. Now here one example. Now example 1. In example 1, the top of a clock tower is observed at an angle of elevation of alpha degrees and the foot of the tower is at the distance of d meters from the tower. From the observer, draw the figure diagram for this data. So given the top of the clock tower, let's take a clock tower. This is clock tower. The top of the clock tower is observed at an angle of elevation. Now this is angle of elevation given as alpha degrees. Alpha degrees, and the foot of the tower is at the distance of d meters from the observer and the tower. So this is given d meters. So this is observer. This is observer, it is a clock tower, and the angle of elevation is alpha degrees. And draw the diagram for this data. So let's give the some vertices A, B, C. So B is a right angle. So triangle ABC is a right angle. This is a diagram for the given question. Now example 2. In example 2, Rinki observes a flower on the ground from the balcony on the of the first floor of a building at an angle of depression beta degrees. The height of the first floor of the building is x meters. Draw the diagram for this data. See here, Rinki is observing a flower on the ground from the balcony of the first floor. So let's take it is a building, and he is observing a flower on the ground from the first floor. So some angle will be made, that is a this is a horizontal line, let P. So here angle of depression is given beta degrees. Now this is beta degrees. Now here it is flower. The height of the first floor of the building is x meters. It is x meters. Draw the building for this. See here, angle of depression is equal to angle of elevation. So it is beta degrees. Let give some vertices ABC. So triangle ABC is a right angle triangle where angle of depression is beta degrees, and given the height of the building is x meters. Now third example, in third example, a large balloon has been tied with a rope and it is floating in the air. A person has observed the balloon from the top of the building at an angle of elevation theta 1 and the foot of the rope at the angle of depression of theta 2. The height of the building is h feet. Draw the diagram for this data. Here one balloon is floating. Let's take it is a balloon. Okay, this is a bottom of the balloon and this is the top of a balloon. A large balloon has been tied with a rope and it is floating in the air. A person has observed the balloon from the top of the building. Let's take it is a building, and he observed from the top of the building. At angle of elevation is theta degree, theta 1. Now this is theta 1. And the floating of the rope at an angle of depression is theta 2. This is angle of depression from depression of theta 2. So let's take it is theta 2 and join this. So this angle of depression is equal to angle of elevation. This is theta 2. Theta 2. The height of the building is h feet. This is the building is h meters. Draw the diagram for this. So after drawing that, let's give the vertices A, B, C, D, E. Now this is a figure for a required. So when you are observing, what is the length of the balloon along with the rope is the length of the building plus CE, because it is a rectangle. In a rectangle, opposite sides are equal. So AD is equal to BC. So length of the balloon with the rope is BC plus CE. So if we are able to find out CE, we can find out the length of the balloon with the rope. Now example 4. A boy observed the top of the electric pole at an angle of elevation of 60 degrees when the observation point is 8 meters away from the foot of the pole. Find the height of the pole. See, a boy is observing an electric pole. Let's take it is electric pole. The given angle of elevation is 60 degrees when the observation point is 80 meters away from the foot of the pole. Find the height of the pole. So what is given? Given distance between pole and observer is equal to 8 meters, and angle of elevation of the pole is equal to 60 degrees. Now find height of the building, height of the pole, electric pole. So let us assume height of the pole is equal to h meters. Height of the pole is h meters. Now we know the one side of the triangle and one angle. So based on that, now try to find out for finding AB. Now choose a trigonometric ratio where involving this AB side and OB side. So this AB will become opposite side and OB will become adjacent side. Now the required trigonometric ratio is tan theta. So tan 60, if you find out tan 60, it is opposite side by adjacent side. To find AB, choose the trigonometric ratios involving side AB, comma OB. So side AB will become the opposite side and side OB will become the adjacent side. So the required trigonometric ratio is tan, but we are with respect to 60 degrees we are taking. So tan 60 is equal to adjacent opposite side by adjacent side. So h by 8 meters. Now what is the value of tan 60? Tan 60 is root 3 is equal to h by 8. Now h value is height of the building, height of the pole is 8 root 3 meters. Therefore height of the electric pole is 8 root 3 meters. Let's move into the next question. Now example 5. In example 5, Rajender observes a person standing on the ground from a helicopter at an angle of depression 45 degrees. If the helicopter flies at a height of 500 meters from the ground, what is the distance of the person from the Rajender? See, Rajendra observes a person standing in the ground from the helicopter. See, let's take this is a point of helicopter. He is observing a person. He is standing on the ground at an angle of depression. See, this is angle of depression. It is 45 degrees. This is a person 45 degrees. If the helicopter flies at a height of 500 meters, it is 500 meters from the ground, what is the distance of the person from the Rajendra? Now let's find out what is here. Let's give some vertices ABC and let's find out the distance between the Rajendra and the observer is x. Now here angle of depression is equal to angle of elevation. So it is 45 degrees. Now we know the one side of this triangle and one angle, we can able to find out whatever the required values. Given height of the is equal to 500 meters and angle of depression is equal to 45 degrees. Let's find out what is the distance of the person from the Rajendra. Here angle of depression is equal to angle of elevation. Now we want a distance between these two is nothing but AC. So let assume distance between Rajendra and a person is equal to x meters. Now for finding x meters, finding the x meters, now choose a one trigonometric ratio where involving AC and BC. So with respect to angle 45, BC will become the opposite side and AC will become the hypotenuse. Now choose a trigonometric ratio involving opposite side and hypotenuse. It is nothing but sine 45, sine theta. Now sine 45 is equal to BC by AC. Sine 45 is 1 by root 2, BC is 500 by AC is x. X is equal to 500 root 2 meters. Now distance between the Rajendra and a person is 500 root 2 meters. Let's move into the next question.
Add-on solutions. Add-on desired.